Okay, so for this page, they are explaining inverse and inverse relation. So this is relation X, relation Y. So what they want you to do is they want you to take this and turn it into this. How do you do that? You take your X's and then change them for the Y. So you're flipping X's and Y's. So 1, 9, 4, and 0. Those are your X's right now. And then they want you to turn them and change places with range. So you're going to flip these two. Basically, the range becomes your domain, and the domain becomes your range. So this is now domain and range, but obviously now this is called domain and this is called range. So you're just flipping each coordinate X and Y. So 1 is changing places with the 3. So you see here, they flip places. 9 and -8 flip places. 4 and 2, -4 and 2 flip places. 0 and 5 flipped places. That is called inverse of relation. So inverse of relation. So here, you can make a note, flip X and Y values. So that's inverse of relation. Inverse of function, as we said in the other page, how do you know if something is a function? If X does not repeat, right? So in this case, X is not repeating. So we're good. And then our Y's, for this one, for inverse, I'm going to give you a tip. You're going to look at Y or range, right? Because Y and range are the same thing. Are the Y's repeating? If the Y's are repeating, that means when you flip your X's and your Y's, it's no longer going to be a function. Because, for example, in A and B, they're flipping places, right? So 0 and 3 become 3, 0. 2, 3 become 3, 2. And 4, 7 become 7, 4. So when they flipped, now the X's are repeating. So these two are not inverse functions, because when they change places, the X's end up repeating. Why? Because in the first one, A, the Y was repeating. So if you look at the numbers, when they're asking you to do inverse function, if you look at the Y's, if they're repeating, that means that the inverse is not going to be a function. So that's with pairs. And then with equation, what they want you to do is, it explains it here. So this is your normal equation, right? Y is on the left side, equals X plus or minus a number, right? So this is your regular. The way you do inverse of this equation is you're going to flip X and Y the same way you do with your ordered pairs. So if you see here, X and Y changed places. So now X is out here and Y is in here. And then you solve for Y, or for Y. So you now have X minus 2Y plus 4. The goal is still to get Y by itself. So I'm going to move 4 by doing the opposite. minus 4. So now you have x minus 4 equals 2y, as you see here, right? And then to get the y by itself, here, you divide by 2. Divide by 2, which is what you have here. So that is the inverse. And then I'll go through these again with you on the next page, or when the examples come up. So just to review this page, inverse relation is when you flip the coordinates. Inverse function is after you flip the coordinates, are they still a function? Again, the key is to look at the y's before you flip them. Do they repeat? If they repeat, you know that when you flip them, it's not going to be a function. Okay, so here they just want you to flip the values. So x's and y's. So inverse of b, inverse, okay, because it goes a, b. Okay, so inverse. So instead of 0, 5, I'm going to have 5, 0. And then instead of 10, 16, I'm going to have 16, 10. So that's how you do that. The next one, we've got 3, 8, and I'm going to change it for 8, 3. Negative 4, negative 1. So again, you're just flipping the x and y. And 4 and negative 13. Okay, so you can do those. Okay, so for number 6, let's go to the notebook. So y equals 9x minus 2. 9x minus 2. So what are you going to do? Flip or change x and y. So your new equation, hello, oh, down here. Your new equation is now x equals 9y minus 2. And then you're going to solve for y. So you're still solving for y. So I want y to be by itself, so I'm going to add 2 on both sides. So that becomes x plus 2 equals 9y. Next, divide by 9 to get y by itself, and divide everything by 9. So 9 is now canceled, and you're left with y equals x plus 2 over 9. So that is the inverse. Inverse. Okay? I'll do another one. Let's do I'll do number 7. X plus y. X plus y. So number 7. X plus y equals 4. Okay, so first thing is these are not supposed to be next to each other. It's supposed to be y by itself. X belongs on this side. So in this case, we know we're going to end up flipping x and y. So you could move y over and leave x, but just because I want you to understand what I'm doing, I'm gonna change it first into y-intercept form. So y is supposed to be by itself. We subtract x on both sides. So now y is by itself. And we've got negative x plus 4. And I just put this number in the front because x goes first. And then we've got, so now I'm going to flip my y, because remember, that's the point, is to flip x and y. So I've got negative, no, sorry, not negative x. X equals negative y, because the negative stays here. We're only flipping the letters. Plus 4. I want y by itself, so I'm going to move 4 by doing the opposite. So we've got x minus 4 equals negative y. So remember that there's an invisible 1 here. So this is actually negative 1y. So we're going to divide by negative 1 and divide all of this by negative 1. So this is now canceled, and we're left with y equals x minus 4 over negative 1. Or you can write this, because the negative goes on the side, so this becomes negative and this one becomes positive. So if you want, you could write it as negative x plus 1, negative x plus 4 over 1. It's the same thing though. So these are both right answers, just so you know. So we've got negative x plus 4 over 1. Y equals negative x plus 4 over 1. And number 6 was x plus 2 over 9. Over 9. Okay, so you can do those. Okay, so here they want you to do the inverse. They want you to do the in like flipping these, so inverse, and they want you to put whether or not the result is going to be a function. So again, a quick way to do this is look at the y's. If the y's are repeating, then it's not going to be a function. In this case, this one is not repeating, so yes, this is going to be a function. Are the y's repeating here? Yes, so that means no function. Are these repeating? No, so yes, function. Are these repeating? No, so yes, function. Are these repeating? 2, 2. Yes, so no function. Okay, so you can do the other 3. And then they just want you to write the inverse. Inverse each function, then determine. So again, we're just going to flip x and y. So now we've got 4, 1 and 9 and negative 7. And then for this one, we've got 0, 2, 1, negative 8, 0, 7. Okay, and the reason again why this is not a function anymore is because our x's are now repeating. So don't forget, that's the reason why it's not a function anymore, because in order for it to be a function, the x's cannot repeat, right? But when you inverse it, we're going off the y's. So if the y's repeat, that means the inverse is not a function. Okay, so you can do those. Okay. For this, they want you to do a table. So again, XY table based off of this equation. So first thing is we need to make it y equals mx plus b form. So negative 2y, we've got 4x here. So this is on the wrong side. So we're going to move that by doing the opposite, which is minus 4x. So we've got negative 2 equals negative 4x plus 8. And again, I just move this to the front because x goes first. How do you get rid of the negative 2? You divide by negative 2, divide by negative 2. So y equals positive 2 because negative 4 divided by negative 2 is positive. And then negative 8 divided by, positive 8 divided by negative 2 is negative 4. So this is now the equation that you're going to use to plug in. So if you remember what we did on the first 5 pages, you're going to plug in some values for x. In this case, they gave you 1, 2, 3, 4, 5 values. And then if you notice, the 3 that I gave you earlier are right there. So, but I'm going to show you a trick for this. If you graph these first, so make x 0 and then make y 0, all the rest of them, you can find them just by following the line. So, for example, if using this equation right here, the blue one right here, if I make x 0, 0 times 2 is 0, 0 minus 4 is negative 4. And then if I plug in 0 for y, which is called the y and x intercept, if I move over the 4 and solve for x, 2x, and then divide by 2, 4 divided by 2 is 2. So if you see right here, 0 and 2. That's where these 2 dots come from. So if you notice, this is 2, 0, and this is 0, negative 4. This is called y and x intercept. Okay, and then all the other numbers, you can just find them on here. So if you go to 1, positive 1, and go down until you hit the line, it's at negative 2, which is right here. If you go to negative 1 and go down until you hit the line, it's at negative 6, which is right here. And then if you go to negative 2 and go down until you hit the line, it's at negative 8. Negative 8. So you didn't have to do all this work, or you didn't have to plug in a lot of numbers for x. If you just put 0 for x and 0 for y, all the rest of them will come up. So you'll see that again in a minute. And then from here, they want you to do the vertical line test to see if it's a function. So if we throw our line, throw the line, this is a function because each line only has one circle on them. So let's do some examples. Actually, no, they're going to explain to you. So they just want you to see, they give you an equation, y equals 2. That means that there's no x value. So there's no up and down coordinate. That's what that means. So if they give you y equals something, whatever number, it's always going to go across. So if they give you y equals negative 4, your answer is going to be this. If they give you y equals 3, your answer is going to be this. If they give you y equals -5, then it will be here. So if you want to make a note, y equals number, the line goes from left to right, which is called a horizontal line. For x, it goes up and down, which is called vertical line. Okay, so, and it's not a function. So y equals, yes, function. S equals, no, not function. Okay, so if it goes sideways, then yes, it is a function. If it just goes down, then it is not a function. And then for this, you see how they didn't give you a value for either one, and it equals 0. It doesn't matter what numbers you plug here, the answer is going to be the opposite. So 0 and 0 are the only ones that are not opposite. But 1 and -1 are opposite. 2 and -2. -1, +1. -2, +2. If I put -3, +3. If I put -5, +5 is the opposite. Okay, so make sure you study those three kinds of equations. Oh, also, this is a function, because if you throw the line, it only hits once. Also, no x's are repeating, so that's a function. Okay, they want you to be able to know this just by looking at the graph. So again, if it goes up and down, no graph, no function. If it goes vertical, yes, function. And if it's one of these, then yes, function. Okay. Okay, so we're going to practice what we did earlier. The first thing is to change the equation into the proper format. So we have x plus y equals 2. X plus y equals 2. And we have an xy table with -1, 0, 1, which are the ones that I told you, 2 and 3. So -1, 0, 1, 2, 3. So they have 1, 2, 3, 4, 5. They want at least 5 values, and it says it in the instructions. So first thing, we need to change the equation. So it's supposed to be y equals mx plus b, which is a whole number here, or a number, and the number goes here. So y is in the right place. It's on the left side of the equal sign, so the y can stay there. X needs to move, so we're going to do the opposite sign, minus x. So we've got y equals -x plus 2. Again, I put x in the front because that's the format, which is right here. So there's an invisible 1 here, just so you know. That way when you plug in, you don't forget to multiply times -1. So let's start plugging in our numbers. Y equals -1 times -1 plus 2. -1 times -1 is 1. 1 plus 2 is 3. -1 times 0 is 0. 0 plus 2 is 2. And then 1. -1 times 1 is -1 plus 2 equals +1. And 2. -1 times 2 is -2. Plus 2 equals 0. 0. And then last one, 3. Negative 1 times 3 is negative 3 plus 2 equals negative 1. So just looking at, before we go back and graph it, just looking at your x's, no repetition, which means it's going to be a function. So let's go back and, so we've got 3, 2, 1, 0, negative 1. 3, 2, 1, 0, negative 1. So yes, this is a function. Okay. And we're going to graph our points. So we've got negative 1 and 3. So you're always going to start on the x line. Okay. So negative 1 is here. And then you're going to go up 1, 2, 3. So right there. 0, 2. So 0 is right here. 1, 2. 2 is right there. 1, 1. So 1 is here, and then you go up 1. We've got 2, 0. So 2 is right here. 0 is right here. So it's going to be right on the line. So just so you know, whenever x, you see how it's next to a 0? If it's x is a number and y is a 0, that means you're going to be on the x. That's called the x-intercept. And if there's a y, a 0 on the x, then the number is going to be on the y line, how it is right here. Okay, last one, positive 3 and negative 1. So 3 right here, negative 1 down here. So they want you to determine whether the relation is a function. So I don't think you have to do the line test because you already verified it by checking if these repeat. But just in case, we're going to go ahead and do the vertical line test because on the other page they did it. So this is good because only one line is on each graph. Okay. Next. So we've got negative 3x equals y minus 6. And then this time they've got negative 3, negative 2, negative 1, 0, 1. So negative 3, negative 2, negative 1, 0, 1. Okay, let's start plugging. Oh, actually, first we have to change the equation. So y equals mx plus b. So y is on the wrong side. X is on the wrong side. 6 can stay where it's at because it's on the right side. So we're going to change this first by doing the opposite sign. So this was positive y. So we're going to change it to negative y. This was positive 3. We're going to change it to negative 3. And negative 6 stays the same. So we've got an invisible 1 here, which means we have to divide by negative 1. Divide by negative 1. Divide by negative 1. So y equals negative 3 and negative 1. The negatives cancel. So 3 divided by 1 is positive 3. And then these cancel as well. 6 divided by 1 is positive 6. Now we can plug in our values. So let's use another color. Okay, so we've got y equals 3. Plug in for x equals 6. So negative 3 goes first. 3 times negative 3 is negative 9 plus 6 equals negative 3. So negative 3. Negative 2. 3 times negative 2 is negative 6. And then negative 6 plus 6 equals 0. Negative 1. 3 times negative 1 is negative 3. Negative 3 plus positive 6 is positive 3. And 0. 3 times 0 is 0. 0 plus 6 is 6. And last one is 1. 3 times 1 is 3. 3 plus 6 is positive 9. So, first thing, no repeating x's. So, yes, that's a function. And we've got negative 3, 0, 3, 6, 9. So, negative 3, 0, 3, 6, 9. And yes, we already determined that it was a function. Okay, so we've got negative 3, negative 3. So negative 3, negative 3. So right there. Negative 2 and 0. So again, if the y is a 0, that means the dot is going to lie on top of the x line. So this is going to be right here. Negative 1 and positive 3. So negative 1, 1, 2, 3. Zero, 6. So 0, 1, 2, 3, 4, 5, 6. And again, this one has a 0. So that means the answer is going to lie on the y line. And last one, 1 and 9. 1. And this is 7, 8, 9 is up here. Okay, so again, if we throw the line, it's good because only one hits. Okay, so I'll take that out so you have a chance to write the dots where they go. Again, and you can pause the video anywhere you need to so you can have time to write everything. Okay. So for this one, they didn't give us the x's, but you're going to do the same thing. Plug in the y to get your x. So what you're going to do is plug in negative 2 here. So you're basically going to do negative 2 squared, negative 1 squared, 0 squared, 1 squared, and 2 squared. So negative 2 squared is negative 2 times negative 2, which is 4. Negative 1 times negative 1 is positive 1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. So we've got some repeating numbers here. So this is not a function. Not a function. So no function. And then if we graph, we've got 4 and negative 2. So 4, negative 2. We've got positive 1 and negative 1. 0, 0. 1, positive 1. And 4, positive 2. So this is called a parabola, just so you know. So if we do the line test for this one, it is not a function, even though we already determined it by finding that they're repeating numbers. Okay, so that's what your graph is going to look like.